Hi dears, in the previous class we were seeing about the uses of ANOVA to test the linearity of regression. Okay, whether there is a linear relationship between the variables x2 and y2. X2 is the independent variable, whereas y2 is the dependent variable. Is there any relationship between x2 and y2? To what extent the relationship is there? So that is known as the linearity of regression. Same way, to test a polynomial regression, that is not only with x2 and y2, the relationship between x means xi, all xi's, that is x1, x2, x3 and so on to xk. Because we have taken k groups, right? The relationship between x1, x2, x3 and so on to xk, that is h1, h0, h0 if you take mu i's, the relationship between mu i's, alpha plus beta 1 xi plus beta 2 x I square plus and so on to beta k xi to the power of k. This sort of relationship is known as a polynomial regression. So for this we are taking the use of ANOVA, that the relationship between x and y can be explained by a polynomial of degree k, right? So this sort of relationship relationship I am talking about, and this is a polynomial relationship. This is what I explained you. That is h naught from mu I, that is equal to alpha plus beta 1 xi plus beta 2 xi square and so on. This sort of relationship is known as a polynomial regression. And then this is what mu1. Okay, if I take mu1 is related to x1, x2 and so on to xk, right? x1, x2 and so on to xk. And this is known as a polynomial relationship. The other one is some other uses of ANOVA. ANOVA has many uses. Another use is test of homogeneity of a group of regression coefficients. Regression coefficients, no, this beta 1, beta 2, beta 3 and so on to beta k, they are said to be the regression coefficients. Whether these coefficients are homogeneous. So this ANOVA helps us to check the linearity, the homogeneity of the group of regression coefficients. The second one is, I'll show you, I'll write it down for you. Yes, some other uses of ANOVA, this is what I'm discussing about. And then the first use is to test the analysis technique of, means to test the first use I was telling about the test of homogeneity of group of regression coefficient. The second one is test of equality of regression equations from P groups. Whether these P groups or these regressions, there is an equality relationship holds. And these are the uses of ANOVA. Now we are going to learn about the ANOVA technique, means one sum we will be solving. Before that I will explain about what is ANOVA. Analysis of variance, the short we call it as ANOVA. Analysis of variance is an extremely useful technique concerning researchers in the field of economics, biology, education, psychology, sociology, business, industry, and in researchers of several other disciplines. So this technique is used when the multiple sample cases are involved. If there are two samples, then we go for t-test. If multiple samples are there, naturally we go for this ANOVA. Right? If there are multiple samples, we go for ANOVA. Right? As stated earlier, the significance of the difference between the means of two samples can be judged through either z-test or t-test. When the sample size is small, then we go for the t-test, that is 30 lesser than 30. If the sample size is more than 30, we go for the z-test, provided only there are two groups. But the difficulty arises when we happen to examine the significance of difference amounts more than two sample means at the same time. If there are more than two sample means, then we have to go for ANOVA. Now suppose we are having sample 1, sample 2, sample 3 and sample 4. Okay, these samples are taken from where? Obviously from the population. Okay, sample 1 is taken from population 1, sample 2 is taken from population 2, sample 3 is taken from population 3, sample 4 is taken from population 4. right? And we are going to see, is there any significant difference between the means of this population parameter, that is mu1, mu2, mu3, and in order to test this, what technique we are using? Obviously, it is the ANOVA technique. So ANOVA technique enables us to perform this simultaneous test. Okay, simultaneously we are going to check the is there any difference between this mu1, mu2, mu3 and mu4? What sort of difference? Significant difference. Sometimes difference may be there. Whether the difference is significant or not, that is checked using the ANOVA technique. Okay, as I explained you before, mu1 is nothing but the population P1. P1's mean is mu1. Okay, same way P2's population P2. Okay, sample S2 is taken from what? Population P2. Therefore, P2's mean is mu2. Similarly, it goes on. Therefore, H naught. What is that? Null hypothesis. Okay, null hypothesis. That is there is no significant difference between mean mu1 equal to mu2 equal to mu3 equal to mu4. No significant difference. That is known as the null hypothesis, right? So, what will be the alternative hypothesis? Will be H1, that is mu1 not equal to mu2, not equal to mu3, not equal to mu4. The ANOVA technique enables us to perform this test simultaneously, and as such, they considered to be the important tool for researcher. It is said to be the important tool, okay, in the hands of researcher. Using this technique, one can draw inferences about whether the samples have drawn from the populations having the same mean. So, you are drawing sample from a population. Those populations mean are one and the same. That is what we are checking. Next is the ANOVA technique is important in the context of all those situations where we want to compare more than two populations, such as in the comparison yield of the crop from several varieties of seeds. Suppose I am having the field, I am dividing the field into 4 parts, and then in the first part I am using variety 1, in the second part variety 2, third part variety 3, okay, fourth part variety 4. Whether there is significant difference between the growth of the crop, production of the crop we are checking now, is there any significant difference between the production? Okay, means that is what we are going to check, right? All this production, the crop production, suppose I am using the drip irrigation, okay, in the first part. In the second part I am going for different. What is that? Water, quantity of water. Maybe that water I might be taking the large quantity of more than that, and great quantity of water. That means quantity of water used in different parts of my field varies. Okay, so that is what I am going to take. So by this way I am going to check whether it has impact. If I use great quantity of water, whether my crop growth is more. Okay, that is what, or vice versa for everything. This is what I am going to check. So this ANOVA helps me to check all this, right? And now I can take the 3 cars also, right? Gasoline mileage for my 3 automobiles. Suppose if I am having 3 cars, C1, C2, C3. So 3 cars are there. I am using same amount of gasoline. Gasoline I can call it as petrol. Same amount of petrol for car C1 and C2 and C3. What is the mileage given by car C1 and car C2 and car C3? Suppose I am filling 1000 rupees petrol for C1, 1000 rupees petrol for C2, 1000 rupees petrol for C3. So same means I have filled the same amount of petrol in all the 3 cars. What is the mileage it is giving? Is there any significant difference between the mileage given by the car C1, C2 and C3? That is what I want to check. For this, simultaneously I want to check. If I want to check simultaneously, the technique used is known as the ANOVA, analysis of variance, right? any significant difference between C1 and C2 and C2 and C3 and then C1 and C3. So I have to conduct, means this is what I want to check, significant difference between C1, C2, C2, C3 and C3, C1. Okay, so simultaneously I am checking all using the ANOVA. Suppose I am having three groups, G1, G2, G3. There are some students, for example, 3 students in group 1, 4 students in group 2, 4 students in group 3. Okay, so I am going to check whether group 1 and group 2 and group 3 and group 1, is there any significant difference between these groups. I may be using different teaching methods for G1, G2 and G3. Which teaching method is best? Okay. Then not only that, within the groups, group 1 is having 3 students, right? Student 1, student 2, student 3. Is there any significant difference between these 3 students? Okay. And is there significant difference between the students of G1 and G2, G2 and G3 and G3 and G1? So difference within the groups and also difference among the between the groups. So within the groups is the difference between 1 and 2, 2 and 3 and 3 and 1. This is significant difference within the group. Significant difference between the groups means, is there any significant difference between G1, G2, G2, G3 and G3, G1? This is within the groups and between the groups. For this, ANOVA is highly useful to us.